All right, so in problem number 3, we're being asked to solve this. And we have blanks for the simplest radical form as well as a decimal equivalent. If it is possible that we will end up with a whole number answer, and if we do end up with a whole number answer, then we'll put the answers in both. So let's get started. I can see you're excited. Andre is laughing at me. All right, so the first thing I notice is that I am not on pen. Once I figure that part out, I notice that that is a square binomial. So I need to factor it as a square binomial. The joke is now just registered with Avery. So Avery, how do I factor x squared plus 18x plus 81? X plus 9 squared. So we have x plus 9 squared is equal to 225. Now, we need to get the binomial unsquared. So how are we going to unsquare the binomial? Yes, Skylar.
Square root both sides.
I'll square root both sides. So the square root of the quantity x plus 9 squared is, yes, Aiden?
X plus 9.
X plus 9. The square root of 225 is what, Mr. Howland? Excuse me? That's one of them. Plus or minus 15. Because negative 15 times negative 15 is also 225. All right. So then what will I do to both sides to get the x all by itself, Mr. Wester? Let's subtract 9. So I get x is equal to negative 9 plus or minus 15. Well, I can't really leave the answer like that because it is not in the simplest form. So let's simplify it further. Negative 9 plus 15 is going to equal 6. So x is equal to 6. Negative 9 minus 15 is going to equal negative 24. Now, these little squiggly brackets, they actually mean something different in math. It's not just a fancy parenthesis. It is telling me that I am giving you a solution set. So the solution set is 6 and negative 24, and I would go ahead and write that 6 and negative 24. And it's important to have the squiggly brackets because otherwise, if I use normal parentheses, it looks an awful lot like a coordinate point. And the answer is not, in this case, 6 comma negative 24 on a grid. It's 6 comma 0 and negative 24 comma 0. It is the x-intercepts. All right, and then my decimal obviously is going to be the same thing. Questions thus far? Yes, sir.
Do you have to have those squiggly brackets for right now?
You really should. Don't worry too much. All right. For problem number 7, we were being asked to factor this, or sorry, to solve this using the method called completing the square. So we are going to complete the square for this problem. And in order to complete the square, I need to have a first term, a quadratic term that is a perfect square. Do I have that? Yes. But I really need the first term not only to be a perfect square, I need it to have a coefficient of 1. I also need to have a blank over here for the constant so that I can add a number that would make a perfect a square binomial. So my first step in this problem is to get that 5 over to the other side. So what am I going to do to both sides to get that 5 on the other side, Mr. Abram? Let's subtract 5. So I get 4x squared plus 12x plus something is equal to -5 because I subtracted both sides by 5. But I still do not have a coefficient of 1 here. So what am I going to do to get me that coefficient, Jameson? Let's divide by 4. And when we divide by 4, we have to divide everything by 4. And now I'm going to work over here. So we end up with x squared plus 3x plus something. I don't know what that something is yet. Is equal to -5/4. And it's okay to have that fraction. Now my next step is to find the value that would make this a square binomial. And in order to do that, I need to take my coefficient of my linear term, and I'm going to divide that by 2. Well, that's just equal to 3/2. And then to figure out what's going to go in this blank, I must square it. Oh, that's convenient. I get 9/4. So I have a denominator of 4 on both sides. That makes me happy. The reason why that makes me happy is because if I add 9/4 to this side, I must also add 9/4 to the other side of the equal sign. All right, so we have x squared plus 3x plus 9/4. But wait a second. What can this be factored to? What can that be factored to? Someone I have not heard from yet. Grace? I'll give you that.
Plus 3 halves squared equals
okay.
1. Or I guess, yeah.
Equals. -5 plus 9 is 4. 4/4 is 1. Oh, that's really convenient, isn't it? That is helpful. All right. So what am I going to do to both sides to get that x out of there? All right. Oh, how about Jake? Let's take the square root of both sides. So, Jake, what do I get now? Plus or minus 1. All right. Because the square root of 1 is 1. What will I do to both sides? Ethan Hindman!
Well, then you subtract 3 halves.
Let's subtract 3 halves. I may have done that for your mom's benefit. So we end up with -3/2 plus or minus 1. Now, is this in simplest form? No. So we need to go ahead and simplify this. So I have -1/2, right? Because 3/2 is equal to 1/2. So I have -1/2 plus 1. What's -1/2? 1 and 1/2 plus 1? Aiden.
0.25 or -0.25.
Not exactly, not exactly. So we have -1.5 plus 1. So -1 plus 1 would be 0, and I still have that negative. Right, so we have -0.5. Perfect. All right, excellent. And so then we have -1.5 minus 1. And what will that get me?
Oh, -2.5.
Perfect, -2.5. And I would put that answer in both of these blanks. So that was solving this using the method of completing the square. I see that nobody beat me to the answer because I didn't hear any.
Eureka! I got it!
Oh, okay. Now we have it. Okay. Okay. Problem number 11. In problem 11, we were asked to solve using the quadratic formula. If I hear another fidget spinner, I'm taking it for the rest of your life.
That's true.
Wait,
right there.
But aren't you gonna die before he dies?
We'll see about that. And right now, I'm not sure your life expectancy is looking too good. Oh, man. All right. I know. Yeah, that's the only part you're going to listen to. I get it. All right. Yeah. It's okay. I'll just edit it out. It never happened. I don't know what you're talking about. All right.
It's a big bleep.
Yeah. Problem number 11. So we're going to use the quadratic formula to solve this. And we need to have everything on one side of the equal sign and equal to 0. Have it equal to 0. So the first thing I'm going to do is I'm going to add 5 and, I'm going to subtract 5 and add 4x squared to both sides. And so I will end up with 4x squared plus 2x minus 5 is equal to 0. Yes, sir?
Why couldn't you just subtract the 2x?
I could have, but I kind of like having the quadratic term positive. But you're right, you could have done it, and that's fine. All right, and so now I already know that my a value will be 4, my b value will be 2, and my c value will be -5. And the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a.
You did it differently than yourself.
I know. Mine sounds better.
X equals
Ooh. All right, so here we go. B is 2. So we have negative 2 plus or minus the square root of 2 squared minus 4 times a, which is 4, times c, which is -5. And that is all over 2 times 4. I thought it was a fire drill for a second. So then, looking at the discriminant, I have 2 squared, which is better known as 4. So we have the square root of 4. -4 times 4 times -5 is going to be positive 80, because the negative times the negative is a positive. 4 times 5 is 20. 20 times 4 is 80. So we have 4 plus 80. We still have our plus or minus -2 all over 8. Doesn't sound as good with that. Need more a number with more syllables. So then, let's combine terms in the discriminant. 4 plus 80 is 84. So we now have -2 plus or minus the square root of 84. And that is all over 8. But wait a second. You know that the square root of 84, well, that has a perfect square factor, doesn't it? So I'm going to go over here. The square root of 84 can be described as the square root of 4 times the square root of, I think it's 21. 16 and 5. I do not think 16 and 5 equals 84. Now, we'll wait. So the square root of 4 is 2. So we have 2 times the square root of 21. And so I'm going to, since this is simplest radical form, I'm going to erase the square root of 84. You can just write another line because you have more space. And I'm going to write 2 times the square root of 21. Now, I am willing to bet right now that Avery Shunnison has noticed that -2, 2, and 8 all share a factor. What factor do they share? I can't hear you, sir.
2.
2, okay. So, 2 divided by 2 is 1. So we end up with negative 1 plus or minus 2 divided by 2 is 1 times the square root of 21. 8 divided by 2 is 4. So right now we know that the simplest radical form answer is going to be negative 1 plus or minus the square root of 21 all over 4. So we know that to be true. But we also would like a decimal equivalent. We also want a decimal equivalent. So I'm going to pull out my calculator. And so we take the squirt of 21. Squirt. You know, just like the little turtle in Nemo.
No. No, it's the jellyfish.
Yeah.
No, the jellyfish is squishy. We're good.
All right. Now that we have the names set for Finding Nemo. So the square root of 21 is this beautiful number right there. Let's add to it negative 1. So plus negative 1. And then we're going to divide it by 4. And so we get 0.8. Oh, but wait a second. That's a 9. If we're rounding to the nearest hundredth. All right, we're going to go up to all right. Now for the negative answer. So we again will take the square root just so Grace makes that face again. The squirt of 21. And this time it is going to be negative because we have plus or minus. And we're going to add to that negative 1. And then we're going to divide by 4. And we get negative 1.3. Oh, 4. Same thing. Check that out. So my solution set is 0.9 and negative 1.4. Yes, you are.
Wait, what's it called? The square again? What is what are we supposed to do with the square?
Complete the square?
For the second one.
Complete the square. Okay, if you can hear me, clap once. All right. Finally, the last problem, probably the easiest of the 4, finding the discriminant and determining how many roots we have. So the discriminant is simply the term inside the square root of the quadratic formula. So it is the square root, b squared minus 4ac. Nope, that's not part of the discriminant. So, the a value is 4, the b value is 20, the c value is 25. So let's plug in those numbers. So we have 20 squared minus 4 times 4 times 20. So 20 squared is, I'm sorry, that's 25, my fault. So we have 20 squared, which is a nice round 400, minus, negative 4 times 4 is 16, 16 times 25 is also 400. So we have a discriminant of 0. If we have a discriminant of 0, we have exactly 1 real root.
Eureka, I found it.
Eureka, I found it.
On the advanced one, on that one, I did it and I solved it all out.
Oh, well, that would give you the answer as well.